are in chapter 5. Can you believe it? We're already at chapter 5.
Well,
I don't think we skipped anything.
how many chapters are
13, I presume.
there?
And we're talking about use case diagrams. So we're going to talk about UML, which we mentioned before. Use case diagram, what is it? What are its components? How to show relationships in the diagram, and some questions from some exams. So modeling. Software engineering requires abstract thinking from the software engineer. Why abstract thinking? Because you have to take an idea from the physical world and create a model to express the idea. In other words, like if I see a glasses, so glasses is a physical thing. If I have the word glasses, that if I try to model what pair of glasses, show the uses of it, that's taking something concrete and making it abstract. So that's what you have to do also in computer with this. You have a concrete idea of what your program is going to do, but you have to turn it into a model, which is it's like a translation of it. A model which shows idea. Abstraction by modeling. A model is an abstraction of the system by a graphical representation or by some table or formula. I don't know exactly what they mean by formula. A model shows a certain part of the system. In other words, not the whole system necessarily. One model could show, or an aspect of it. It could be the whole system, but only a certain aspect of the system. What are the physical building parts of the system, but not how do they interact? Right? If a model doesn't necessarily show everything about the system. It could be part of the system, it could be the whole system, but only one aspect of it. We are addressing the main features of the system, ignoring other, albeit very important, other details. Sometimes you make a model of the essence of the feature because you want to communicate the main idea, and you don't want to get lost in the weeds. When we emphasize only part of the system or only a certain view of the system it's easier for us to understand the system. We can understand and organize complex systems. In other words, by trying to make it less complex, you can ultimately succeed in showing a complex system because you've made it simpler. And then you can later on add parts to it. So this is just about where UML came from. This is a kind of history. The development well, let's put this down, of general object-oriented software engineering. So in the beginning of object-oriented design, which means design with classes, for example. Right before object-oriented, you just wrote functions. Every function can be called by anybody. What's the idea of object-oriented is that you combine functionality and data into one entity. And then only that entity can access the data and the functions associated with it, as opposed to it being a free-for-all. Anybody can access data or anybody can access a function. Unless you make you can make a function, if you have an object, then whatever the object, you have to access the data through the function on the object. Anyway, that was in the 1980s. It became more popular. OOP, object-oriented programming, and OOAD, object-oriented architectural design, I think it stands for. The beginning, there was a war of methods.
Wait, can I ask something?
Yeah.
So I actually still don't get why it's necessary to make things private within your own program. Like I get if it's like someone else is accessing it, but like.
Because basically you want to limit your question is why, if it's my program and I'm writing it, why shouldn't I make everything public? The answer is there's a kind of what? Yeah, it's still be categorized and make it public. The answer is there's like, I forget exactly the term. I used to like to say like the rule of limited access, or basically you only give people access to or yourself access to the extent you need it. Because if everything is public, then you might by mistake change something or think that it's okay to change something. Just because you wrote it doesn't mean you remember everything that you did a week ago or 2 weeks ago or a year ago. So for example, if you would, let's say, have a string for the date, if you might want to only have a function, you don't want to access that data directly, because maybe you'll misspell November. Maybe you want a function that when you put in the date, it only lets you put in November spelled correctly. So you say, well, I'm doing it. If I want to spell November incorrectly, that's my choice. No, you want to control the way you interact with your objects, because when you built the object, you defined exactly how to use it. I'm just giving you that's the most simple, right?
Yeah.
And you want to maintain that. You know, if somebody's, maybe there's a special function to change the birth date of somebody, because it has other ramifications to other places. And if you would just let somebody directly access that data, you might do it wrong. That's why the data should be private. Now you can have public functions to access the data. You're saying, why have private functions? In general, functions should be public unless unless they are what's like I would say auxiliary functions, functions that another function is using. And then you don't want that function to be accessed directly. You want it's only for as an auxiliary function for some other public function. But ultimately, you have to be able to have a way to get to that. To get to that function, how would you get to a private function? Through a public function. So why would you do that? For, like I said, for an auxiliary purpose. You don't want people to access it directly, because there's only this other function knows how to use that function or is permitted to use that function. Essentially, you're limiting yourself intentionally, you know, like it's on a need to know basis. If you don't need that information, you want to make it private. Basically the rule is make everything private unless you have to have it public.
Yeah, cool, that makes sense, thanks.
Sure, okay, so what is this war of methods? The idea is like this, that when there was this new thing called object-oriented programming, they had to figure out how to draw just a diagram. So different people came up with different methods of how to draw it. How do you show a class? Do you show it in a circle? Do you show it in a square? Do you capitalize it? Do you lowercase it? Like, you know, how do you show, what are all the symbols? How do you show that a function is private? Is it a plus symbol? Is it an ampersand? Is it a number sign? What should the symbols be, and how should you represent it? So people basically they were teaching, or they were working at a company, and they just started doing something. So then it became that there were different ways of doing it, and that's what we mean by battle of the or war of the methods, really, because whose method is better. And the main flag bearers of the war method were these three people: Grady Booch, James Brumbaugh, and Ivar Jacobson. The main one I always remember is Grady Booch. He's kind of famous because he's kind of interesting guy because he has long hair. Anyway, in 1996, there was the end of the war when the three heroes united, and united their methods for one method called the unified process. And then a general arbitrary, then it became UML, which stands for Unified Modeling Language, and that's why the word U is there. That's why the letter U, the unified. The idea is that we took a little bit of some of the ideas that Booch had, some of the ideas that Brumbaugh, and some Jacobson, and we came up with a method. All three of those guys, each one came out with their own book, and they published how it should be done. And so then they got together and came up with a unified method, and that became UML. I don't know much. The unified process also exists. I'm not really sure what the purpose of it is. But it's a process. In other words, this is a modeling language, and this is the process. This is the UP is just to describe a project under development. How do you define? How do you show development? I hear the pictures are. Oh, well, Grady Booch and these other people. Okay. See, he's got long hair. Okay, the birth of UML. The first version was published in 1997. I actually remember that. I was a student at that time in my whole life, and I remember that we were learning already this diagramming of object-oriented stuff, but UML didn't exist yet, and then that was new, because you could, and these three people are called the Three Amigos, and they didn't copyright UML. They donated it to something called OMG, Object Management Group, and they standardized it. And that was also in 97, but 3 months later. It's a nonprofit, OMG. that promotes standardization of object-oriented technologies by issuing guidelines and specifications such as UML. Now, it's a guideline of how to do it. The companies in the organization are these big companies, HP, IBM, Microsoft, Oracle, Rational Software, which I think is since bought by IBM, as I recall. But at one point it was a separate company. History of object-oriented methods and notations. You have to memorize this chart for the exam. Everything on it and how it's related to itself. No, just kidding. Of course. No, this is just a picture. Okay. This is just the different methods, all these different people, Coleman, Jacobson, all these different methods and how they each one developed and how they and then they became this and until everything got here's unified process, here's UML. There's something called Open OML that never got further. These are just the development of it. Now here, I don't know if I showed you this in the very first lecture. I think I probably did. This is a diagram of diagrams, right? Because everything is inheriting from diagram. These are all diagrams. I like this. Behavioral diagrams and structure diagrams. There are two kinds of diagrams, general types of diagrams. Behavioral describes the dynamic behavior of the diagram of the system. If you're diagramming, let's say, software, and you want to say, what's the first thing that happens? First you log in. So you would have a beginning point. But in a structured diagram, you wouldn't show where the beginning is. You just show there's a class for login, there's a class for this, there's all these different classes. You wouldn't show how a user progresses through or how an event occurs through the system. So these behavioral diagrams show the use of the system, whereas the structural show the components of the system. And the main one we'll do over here is really the class diagram, which you know. Now, this is all UML. These are all UML. So a lot of people think that class diagram, well, if that's UML, it's part of UML, but UML is much bigger. For example, activity diagrams and use case diagrams will also do, and they are also part of UML, but they are dynamic diagrams. They show the movement. And that's what we're going to do today, actually. So while modeling a system, one should capture, like I said, the static behavior in, let's say, the class diagram, and the dynamic behavior in, let's say, use case diagram. Dynamic behavior means behavior of the system in action processing, right? What I said. In UML, there are 5 diagrams available that model dynamic nature: use case, collaboration diagram, sequence activity, state chart. So like I said, we're only going to do use case and what did I say? Activity diagram, yeah. Sequence. In the past we've done sequence diagram. So we're doing a activity diagram. Okay. After the initiation phase, we need to characterize the system. In other words, what are the characteristics of the system? The characterization phase analysis includes decisions about this, what are the requirements, details about what the system does. In other words, the initiation phase is writing your initiation document. And then you have to start characterizing what are the what are the requirements. For the purpose of characterizing the system, we can use 2 dynamic behavior diagrams, use case to present the system requirements, and activity diagrams show the logic of each requirement. Right. In other words, the activity diagram, the use case also shows the steps in the diagram. Now, these are behaviors, things you can do with the system. A use case shows you things you can do with the system, and it shows you the steps. An activity diagram shows you maybe the logic, the ifs and the elses. So use case diagrams. A behavioral diagram, as we said, usage scenarios. The purpose of the diagram is to present a functional background of the system using the concept actor's purpose, which will be described in a usage scenario and the dependency between them. All right, so in other words, we're going to show what is the purpose of the system, who is going to use it. Those are called the actors. The general purpose of the usage diagram is to show the actions performed by each actor. The actors' roles will be drawn on the chart. A little bit too much definition before we actually see an example, but I just took the Hebrew and translated it. So this is what the Hebrew people have to suffer through. So You have suffered through it also. Consists of one or more sequence events that describe how the system interacts with users, called actors. We said that already. To achieve a specific business goal or function. I don't know why I have no players, but okay. A use case can have end users or other systems. In other words, the person who uses the use case could be actually not a person, but a system. For example, the IRS might interact with my system of salaries to find out my like how have I paid them, or I might interact with the IRS system to find out what tax bracket to put this person in. An agile software in agile software development, it's customary to call the sequences of events in the scenario stories. So sometimes we'll say that a use case we'll also call it a story. That's just naming. They're written in simple, these use cases are written in simple language, understood by the user or the application expert, rather than in technical jargon. They're sometimes written together by the system analyst, and the users themselves might write them, because he's saying, this is what I want to use the system for. It's for him. It is customary to write the scenario as clear and easy to understand document, simple design. Fine. And systems engineering use cases are used for a more general description of requirements, often describe tasks or goals of stakeholders. Stakeholders are the people that have a stake in this project. So they want to use this system. They may define how and what the use cases are. A definition again. A use case diagram is a graphical depiction. Well, we've got to see one already. A use case diagram shows various use cases and different types of users in the system will often be accompanied by other types of diagrams. So you use it in conjunction with other diagrams. The use case themselves are in either circles or ellipses, and the actors are often shown as stick figures. There's a lot of anticipation till we get to see one. While a use case itself might drill into a lot of detail about every possibility, a use case diagram can give a higher level view of the system. Use case diagrams are the blueprint for your system. Due to their simplistic nature, use case diagrams can be good communication tool for stakeholders. Stakeholders are people who have a stake and they don't necessarily have much knowledge about the technical stuff. So they like to see a stick figure. Everyone understands a stick figure. The drawings attempt to mimic the real world and provide a view for the stakeholder to understand how the system is going to be designed. Oh, here we go, a picture. This is a use case. It's actually not the most simple one. The most simple use case really would just be, let's say this. Client, eat food. That would be it. There's an arrow and an ellipse. And then inside the ellipse, what is the case? I want to use the system to, well, eating food. I hate these examples because they're like real world examples, but how do you program eat food? So another example would be, let's say, buy a pair of pants. That would be a use case, right? I want to go onto a website and buy a pair of a shirt, let's say. I don't want to discriminate against people who don't wear pants, but I want to go to a website and buy a shirt. That is the use case. Now, of course, that use case has steps. I have to log in. I have to choose. I have to search for the kind of shirt I want. I have to put it into my cart. I have to maybe make an account. I have to pay for it. I have to fill in my shipping. Well, there's steps involved in buying a shirt. What do we have here? We have, but this is showing a use case diagram with a waiter. These are an actor. Client is an actor. A cashier is an actor. Cashier accepts payments. Now on the line, you see, we can write what data is going across, accept payment, or what triggers it. In other words, the waiter, notice that everybody's using pay for food, but they're doing different things with pay for food. Client is paying, cashier is getting the payment, and what is the waiter doing? It doesn't even say. Maybe he's drawing up the bill, right? He's maybe putting the things on the bill. The waiter is receiving an order. He gets an order from food, and the chef is also using order of food because he's got to see what the order was. The waiter maybe creates the order, and the chef maybe reads the order. And we'll see. We're not supposed to understand everything here. We'll get into detail, but I'll go through everything anyway. Order food, order wine is an extended version of order food, because not every time do I actually order wine when I order food, but sometimes I do. So it's part of ordering food, and maybe this has special procedures. Maybe you have to show your ID card that show you're over 18. You can't just order wine. It's not just a normal thing. Maybe you have to maybe this, I don't know, special details about how you order it. Cook food, only the chef does. Waiter can serve food, and sometimes he'll serve wine. So we have some extends here. Extending meaning that they are additional aspects to the case that are not always included. Eat food could also include drink wine. All right, kind of a whatever. This is just to get you the basic idea. That is a use case diagram, but we'll see that's not the end of the story. Purpose. In the use case diagram, we present the functional requirements of the system. In other words, you should see everything your system does. You guys are gonna have to do this. This Jacobson, who's one of the people of the three amigos, they call them, described the essence of a use case in this sentence: the way in which a user will use a system. That is the main guideline for it. In other words, how I want to use the system, how do I want to use it? Okay, so because each requirement is modeled in a use case, taken together, the models show what the system must do, right? You put all the use, in other words, it's a little bit confusing, but each one of those actors and circles is called a use case. And then many of them together is also called a use case diagram. But even one, it would be a use case diagram. But if you make a lot of them, then you know what the system is doing. The use case diagram is actually a collection of individual use cases. Each use case is actually a complete execution unit of the system. Each little use case. Okay, and as we saw, the elements of the diagram are the actors, which are stick figures, doctor, patient, actors. The actors are internal or external factors that participate in the execution of a use case. An actor is anyone who initiates a use case or interacts with the use case, right? Like the chef didn't initiate buying order, but he interacted with it. What do we mean by that? They're internal or external? I think because the point is that the actors are external to the system, but another use case could activate another use case. One use case could activate another, so that'd be internal. An actor can be a person, a system, and each actor is marked by a human shape, which is interesting because what does that imply logically? That if you're talking about the IRS system talking to my salary system, it would be represented as a stick figure also, even though the IRS is not a person, because it's an actor. An actor can be a system, and every actor is a human shape. So we have now turned systems into people. An actor can interact with several use cases. These are another component of the diagram. Make an appointment. Perform here. These are these ellipses. And notice that it's an action. Make an appointment is something that I want to use the system for. Perform medical tests is something I want to use the system for. Really, I don't like the idea of perform medical tests, but let's say analyze data from a medical test. Perform a medical test sounds like to me like something outside of the system in the physical world. Like you take a needle and you poke it into somebody and you draw their blood. But the system doesn't do a medical test. The system just is an information system. Use case. Each use case represents a business function of the system, meaning a function that stands in its own right and not a sub-process of a larger process. We'll see. In other words, a business function, when we say business function, what we mean is something that promotes the usefulness of my business, of the business of the project. The project business is to, manage parking spaces. So that's the business of the project. And it should promote that business. And shouldn't be a sub-process of a larger process. Although we'll see that it is. We just saw that it was. For example, buy wine is a sub-process. But that's also kind of a thing I want to do. Okay. For example, figure B is a correct use case, figure A is incorrect. So figure A, yeah, I like this example. Which one is correct? Customer withdraw money, let's say from the cash machine. Is that the way you should write it? Or should you write it like this? Customer, enter card, enter PIN number, select amount, confirm amount, take receipt, remove card. So this is incorrect. Because this is it's not a business that I didn't make my system so that people can enter their PINs. That's not the purpose of the business. The purpose is to withdraw money. The stakeholder is not interested in, I mean, he's interested, but whatever. No, I don't want to say that, but I'll just say this is not a business interest of ours. I didn't make a system so that there should be security, for example. That there should be that people shouldn't be able to break in is not why I made the system. Right, the system I made to find parking spaces. Now, once I have a system, I want to protect it, so there shouldn't be. But I didn't make. It's not the business of my system that it should have protection. So it wouldn't be a use case, even though it might be a big element of the system. But there's no use case that I go and I say, "Give me protection." Okay, so that's a good example of how to understand what to make a use case. There's also something called a system boundary, which is this box. The total number of use cases in the system is shown, as are the actors participating linked through association lines. So that line is called association line. And the people are outside of the boundary, the system boundary. Actually, I had a little bit of a debate with one of the teachers because we said in the beginning lecture, the first lecture, we said that an information system is composed of what? Do you remember what we said it was composed of? An information system? It's composed of hardware, like the computer. What else is it composed of? Software, the logic. What else is it composed of? At least two more things you could think of. Information, data. It has to have data. If it's just empty, it doesn't really do much. And another thing, we also said that at that time, the people. Because the people are part of the system in the sense that they add the data. The data doesn't just come out of the thin air. It is given by people. It represents people. So there has to be people. People are part of the system. I can think about how the people interact with the system. So it becomes confusing. We said there that the people are part of the system. Here we're saying, no, they're outside of the boundary of the system. So that means they're outside of the system. They interact with the system, but they're still diagrammed. We still put them into the picture, but they're outside of the logic of the system. So I was saying we got to come up with a clear way of explaining that. Because we said before they're part of the system, and here we're saying they are not part of the system. So use case component special relationships. So we mentioned this before. These two ones, extend we mentioned, we didn't mention include. There are two special notations. One is include and one is extend. What does it say? Make an appointment includes validate patient records. In other words, what this is saying is you can't make an appointment without also doing validate patient, because we don't want to make an appointment for somebody who is not our patient, is not in our system. Whereas perform medical tests, perform pathological tests is an option in that. It doesn't always, this is a possible extension of the medical test. Now, what's confusing is the direction of the arrows, because, why not just draw them both with the arrows in the same direction? Put the make an appointment down here, and then put the validate patient records up there. Wait just a second. Hello? אתה יכול להשאיר את או בדיר אחת, אולי בדיר אחת יש מישהו, כי דיר אחת, וייסברג, שיר את זה שמה. 6א, פיסה 6א. תודה. Sorry. Yeah, why not just draw it the other way? Make an appointment at the bottom. I mean, it wouldn't change the diagram, right? Doesn't matter. The matter is the direction of the arrow. So what if I wrote make an appointment, and then on top I wrote validate patient records. So then, which is the main thing? Main thing will be on the bottom then. So when you're ever talking about the main thing, the arrow, if the arrow is going away from the main thing, then it's include. If the arrow is going towards the main thing, then it's extend. Right? This is the main thing, perform medical test. And then extending it, I'm pointing towards this thing, is not the main thing. It's an optional part of this. So from this guy's perspective, he's pointing to this. He's saying, I am a part of this. Sometimes. But here he's saying, when the main thing is pointing to somebody, he is saying, I always am a part of this. I'm not a part of this. I always require this. He is a part of me. A little bit confusing. But you could say it makes sense in this way, that perform pathological tests, he always includes perform medical tests, in a sense. He's a subcategory. It's really inheritance. I think it's like inheritance, because this is a general test, and here is a specific kind, like order wine, specific kind of ordering food. Okay, anyway, we also write the word include in these back arrows, and the word extend in these back arrows. Wait a minute, let me just yeah. Okay, so we have a remark here. In UML, anything that is wrapped in these angle bracket is called a stereotype. So include and extend are stereotypes, and you write them actually on the line. So that helps clarify. The arrow's direction is clarified by that. Okay. So now here I just explained what I already said. If a use case named A always uses B, then the relationship between A and B is like this. A includes B. The arrow, the direction doesn't matter. It could be the B is beneath. In the other picture, the B was beneath. It doesn't really matter. In other words, the include mark allows us to include B steps within A steps. Because we're going to see that A, it's not enough to just write, make an appointment. We're going to eventually write a list of what that includes. So if we do A, we may also do the steps of B. Well, we'll always do the steps of B. And extends is in certain circumstances. If A uses B in certain circumstances, then the arrow is the direction is opposite, and we write the word extends, and we say B. Well, we say A sometimes uses B. It improves the behavior of B. Therefore, the arrow is from B to A. The relationship between the client means that the client can run B. What does this line mean? If this is part of this, then why do I draw this line? I don't have to draw this line here. But this line means that I can access B directly without using A. For example, this might be buy a pair of pants, and buying a pair of pants might be include login. Because I can't, if I didn't log in when I selected the pants and I put them in my cart, now it's going to say please log in. So I'm going to do that, but I could also just directly log in and not do anything, not buy anything. So log in could be, in certain circumstances, I do that. Well, actually, right, I mean, whatever. That's maybe a bad case because I can't, let's say I could log in, I don't have to log in. I could buy it anonymously, but I could also log in. Okay, so here's an example. the registrar, the applicant, they both deal with enroll in university. You see that in this example, enroll in university is very general because the registrar doesn't enroll, but she maybe verifies the information that the applicant gave, but it really could be almost a different use case. I'm not sure I like this example so much because really the applicant is enrolling in university. She's doing something else. Maybe maybe she can enroll somebody without the applicant being involved. Maybe the registrar can enroll somebody when the applicant's not around. Maybe, although, fine. I don't like this example because of that. I would say not really, because even if the registrar was the one typing on the computer, the information ultimately is coming from the applicant. So the applicant is doing the action, even if the action is being done through a messenger, through a shliach. Student enrolls in university. That also, what's the difference? Why would a student who's already a student in the university enroll in university? I'm not sure I understand this. Right? You're an applicant to enroll. Maybe enroll in a course. Maybe that's a course, I'm not sure. Perform security check. I guess if you're an international student and you enroll in university, you have to do a security check. But you could also do a security check without any other purpose. Also a weird example. Why would you do a security check if you're not going to enroll? Just want to do security checks all day long? I don't know. Enroll family member in university. What is this? Well, there's no line here. What does that mean? Well, we didn't see that, but this is inheritance. This is actually inheritance. This is a special category of enroll in university. This is from 2004, 20 years ago. Yeah. The components, so relationship of inheritance. So now we're talking about inheritance. You can have inheritance between the actors, a worker, and then you have a secretary, a maintenance person, some other kind of actor, or a cashier. They're all workers. So you could have that, and then you could have worker can do things, and then some things maybe not every worker can do, only the cashier can do. So then you'll have an arrow directly from her. What's the purpose of showing you here? Just write all the names. It's just it's to save the use of connection lines so the diagram is easy to read. Because let's say all these people can do a certain thing, then I have to write lines, lots and lots of lines to that thing. Everybody's going to line to that, and also to that, and also to other things. So I can just make one worker who can do everything. The meaning of inheritance: the son will be able to be linked to any use case that the father is linked to. The opposite is not true. Right, that's kind of obvious. The father can't, well, right. It could be the cashier can do things that not every worker can do. So the worker can't do it, but the cashier can. And here we have inheritance between cases, which we saw already a picture of. Usually when there is a use case that is divided into different types, such as generating a report, there are different types of reports. So then we can use inheritance between them. I mean, we could say generate report, and then we can have generate financial report, generate efficiency report, all kinds of different reports. This means that the successor use case is a type of the use case from which inherited. And when the actor, sometimes I call it player here, but when the actor has a link to the parent use case, he has also a link to the children. In other words, if I have an actor connected to this one, then he also is connected to this one. So here's a more complicated example. Some kind of worker who does checking, some kind of manager, and you see that he can do many things. And here, this worker can do, what is this? Buying a card. And this is buying a one-time card and buying a membership card. And he can do either of these things. And he can also, whenever he buys a card, you have to make a reservation. And here's a worker, and all the workers can do register their time, how much time they've been working that day. But only the person who's in charge of maintenance can do adding a new toilet bowl or something. Or, right, there's certain things that only the maintenance people can do. So that's the idea of that diagram. What are the advantages? Well, it tells you what the system boundaries are. It tells you everything what's in the system and everything what's not in the system. Enables good communication between the client and the developer, because you can see a picture. It's clear once you see the picture, you understand what the system is doing. It guides the development team through the entire development process. You can always go back to it and look at it and say, oh, did we do this use case? Did we finish it? Or do we have, how many have we finished? You can see what the whole project is. Provides a method for planning development work. You can say, these 3 use cases you do, these 3 you do. We can divide up the system. Provides a method for estimating development duration. You can figure out how long it's going to take. See how many use cases. You got 1,000,000 use cases or 2 use cases. It'll take more or less time. Provides a basis for creating software tests. Well, the use case is going to say in the end what's called a precondition and a postcondition. What's supposed to be the situation before and the final event at the end. How will the system have changed because of this use case? So we can create a test to see, did the system actually achieve what it's supposed to? It helps in writing system manuals. If I want to explain what the system does, I have already started the process. Defining customer requirements. Along with the use case diagram, you must attach documentation, textual description. It has a certain structure in a table. Don't just draw the diagram. You have to have a textual description that takes place between description of the interaction that takes place between the user and the system. There are 2 types of descriptions: a short one and a long one. But actually, UML did not define how to do these descriptions. But we, in our class, will define it. And here is a short description. The short use case is just the name, and then it's a table, and then a short description in the next box. The full one will include those 2, but also have more sections. It'll have a precondition and postcondition. Precondition is like what state the system must be in order for you to do this, or what state you must be in. You must be a member, like let's say, to borrow golf clubs, you have to be a member of the, you can't be a guest, you have to be an actual member of the golf, of the country club. So a precondition would be that you're a member of country club in order to check out rental, even to rent, let's say, golf clubs. And a postcondition would be that the golf clubs are no longer in the storeroom and you have them. You have rented them. So they're not, we've marked down in our database that we have one less set of golf clubs. That would be the precondition and the postcondition. And then the main flow, which would be a numbered list of actions for what would be the golf club case. Let's say, show membership card, select golf clubs, pay for golf clubs, write, leave membership card in drawer, so that they can give it, make sure you, or register that you have it. I don't know. Whatever the steps are would be here. That would be the main part of it, actually. And then alternate flow and exception flow. So alternate flows are other ways that the post condition can be met. I like this. This is a very important definition. Alternate flows are other ways that the post condition can be met. Post-condition is that the golf clubs are by you, are in your hands. So other ways. Maybe if you're not a member, but you leave a deposit of $300, you can rent it then. Maybe they have something like that. Or maybe if you're not a member, but the manager approves it, then you can rent it. So that would be an alternate flow, which would skip some steps here, because one of the steps here was, find the membership of this person, identify the person. What are exception flows? Exception flows are ways in which you will not reach the post condition. For example, he doesn't have a membership, his manager didn't approve, and he doesn't have $300 to leave. So we're not gonna, something happened. He tried to rent, but he failed. Okay. Example, given the following simple use case comes from a retail business system. Take customer order. Sales assistant. I don't know what it is. So here's the main flow. Actor enters customer detail. In other words, the actor is, let's say, they said it was the internet, but I think of it differently. I think of it as like a store. You go to the store in the mall, and you come to the checkout and you give a pair of pants. So the cashier maybe brings up, are you a member? And puts in your membership number. Then she swipes the pair of pants through the swiper, and the number of the pants is entered into the system, and the system displays the product details. Actor, now maybe you ordered 16 pairs of pants. She's not going to swipe all 16. She can change the number now. Let's say to 16. And then payment details. Now you got to swipe your card. So the system takes the payment details. And then the customer order is registered. And then you can go home. Can anybody think of an exception flow for that? Think of all the exception flows. Or what could happen when you swipe the number of the pants? What could possibly happen?
Price comes up.
That would be normal. What would be an exception?
Doesn't
recognize it. Maybe these pants, you took them from the other store, and by mistake you came in. You're in the mall, and you came from one store to the other with a pair of pants from the other store. Now you're trying to buy them in the wrong store. She says, sorry, we don't have pants. We don't have that number. Is not in our system. So this number could come up and be wrong. So you can't buy those pants. We're not going to sell them to you. It's not. You just brought in some pants from somewhere else. What other things could happen? The credit card could not be approved. So, but those are the alternate flows. Those are exception flows. What are alternate flows? An alternate flow is after step 4, when the actor enters the required quantity, go back to step 2 for additional products. Maybe he wants to not only buy pants, he wants to buy a hat. So maybe we'll go back to 2. We're not going to go back to 1. We've already got the details. So we go back to 2. And then resume at step 5. So that would be an alternate flow. An alternate flow would be by multiple types of items. Multiple item SKUs, actually the word. You know that word SKU? SKU, it's not a word, it's an acronym. It means like ID number for an item. Include in the table description. So remember we said, also, so here we could do something like this. We could have a situation where we take an item, which we already talked about. We could also return an item. Return an item, like we also get some of the things that are in common. We may also swipe. We also may find enter his membership number. We may also enter the article's ID number. So some of the things are in common. Well, for example, identify a customer might be the same. Might be in both of these things. So instead of leaving all those details here, instead of the steps for identify customer, we could have written them here and here. Instead, what we do is we'll pull them out and make a separate theoretical use case called identify customer, and both of them will include it because they'll always do it. Now, there's no line from sales assistant to identify customer. Why is that? Because that's not a use. You're never going to actually just identify customer. A person's not going to walk into the store in the mall and say, "Hi, can you tell me if I'm a member here or not?" I mean, he could, but in our system, we're not going to let that. If we would allow that, they just comes in and say, "I just want to know." In other words, it could be that you could do it, a workaround that you could pretend he's buying something and then identify it. But do we have a separate use case called identify customers? No. In our system. So how do you show this inheritance, or not inheritance, this including of a separate, how do you show the including of a separate use case in the table? So well, first of all, we're going to show a table of we're going to show identify customer itself. And to the last name, it'll display all the customers. You select one customer. I also don't like these use cases 100% because I don't believe it should say system and system. What the system does is not part of the steps of the actions. The actions are what I do as a user. The reason why they did that here is just to have more than one line here. But really, it's just what I do. So I enter the name, and then of course the system will display something, and then that's step one. I enter a name. Then I select the customer that I want. Now, I put in Cohen. I got 55 Cohens, and now I choose the one. Actor confirms, yes, this is the Cohen that I want. But the fact that the system displays the details is not a step that I do. It's not a conversation. It's not what he does and I do, and he does and I do. Of course, he's doing things, but we don't write those here. We write what I do. At least that's the way I understand it. After step 2, when the system does not display the required customer, actor creates a new customer. So that's an alternate flow. You see why that's not an exception flow? Because if he does not in the system, I can still create him, and I'll still get the same result at the end that I've got now a user. If select add new customers, enter details. Okay, and then we continue. So that's identify customer. Now, I didn't show you yet how to integrate it. So here's how you integrate it. You go back to take customer order, and you say the first step is identify customers. So after actor records customer details, include identify customer. So in parentheses, we're writing that in capital letters, identify customer. And that indicates to us that that's a different use case that we're including in our use case. And then the same things. Some notes. When we execute the use case name take customer order, step number 1 tells us to execute all the steps of the use case name identify customer. Right, that's what I just said. A little bit redundant. Including all the steps of the alternate flow. The syntax for noting include is not in the table is not fixed. That is, the way to mention the include is not also determined. It could be highlighted by placing it in parentheses or quotation marks. I like to do it actually in bold. I think that's the best way. In bold and capitalized, or at least the first letter is capitalized. Please note that the use case name take customer order references the use case. Wait, please note that use case called take customer order references the use case name identify customer. Right, well, that's what they said. But the use case identify customer order, identify customer, does not reference the use case called take customer. As we go back here, there was no mention of just identify customer. There was no mention of who's using me. Because that's not my job. My job is to define me as what I am. Well, I am as this use case. You want to use me? Then you got to say you're using me. That's the user has to say. we can conclude that there is an interaction between the actors and the use case called identify customer. But even though it's not written there, it's only through the interaction that exists between the use case called take customer order and the actor. In other words, the only way we know that he's using this is because we see he's using this and that these ones are using this one. Okay. Now, what about extend? Sell customer specific product. Maybe he ordered ahead of time a skirt with his with a poodle on the bottom. And he brought in the poodle and we stitched it for him, and that's his own skirt. Her, presumably her. I don't know if they still do that. Do they still put poodles on skirts? In the kitchens they do that. Sell customer specific product. So here we have an extended version. So, and we have a main customer specified product. I don't know why we write it twice. Sell customer specific, customer specified. After step 3, when the system display, after step 3, it should be after step 3 of take customer order. When the system displays the product, you see here we are referring to the main one. It should say after step 3 in take customer order. See, this one doesn't refer to him, but this one does refer to him. Actually, that's what the arrows mean. Maybe that's what the arrows mean. That I have to mention him in my, if you remember it that way, I have to mention him in my description because he doesn't know about me. He just says, I'm doing this. Oh, I sometimes do this because he says it. After step 3, when the system displays product details, if the product requires customer specific features, actor enters customer specified requires. That's not the poodle thing, it's a different thing. It's like I wanted a monogram shirt. So now when I'm ordering it, I'm saying what the monogram should be. And then resume step 3 until step 3 when customer order is saved. At this step, the additional customer specified product details must also be saved. So fine, I refer to the one that I am an extension of. In the table explaining the use case, name, take customer order, where will the extension be named? The answer, it will be there. It will be in the alternate flow section. Here. That's why he wrote, I see, he did, that's now I understand. It's a cut and paste. Here he just cut and pasted it, I think. But here, let's see. Yeah, alternate flow. After step 3, this is what, and just again, I don't 100% agree with this. Sorry for not agreeing with this, but I think you just write, customer specific. Just say. If you're going to specify all this over there, why write it twice? This makes sense. If you're going to specify it here, then why do you specify it over there? It doesn't make sense that both refer to each other. He doesn't make sense. Why can't you just write now that the other one is clarified where it comes in and where it ends, just write do customer specific product, period. Customer specified product. Just do that. And it's all written over there. Why write it twice? Another example, we saw this one, order 1. Here's another example. Student, pay fees. Financial institute, pay fees. I don't know how they interact with it. Okay. Teacher, print teaching schedule, teach seminar. So here's it, obtain student grant. I think you get the idea. Using boundaries, to determine the content of releases. This is interesting. You can define, if you want to divide up your project into releases, you can put boxes within boxes. It's called this release 1, release 2 extends that, and release 3 extends that. Or is not really part of that, but it's a different thing, a different release. Okay. Exercise. Use case. In the system for an amusement park, an employee can report hours and check facility integrity. The administrator can add a facility, but must check its integrity when adding the facility. The customer, called the visitor, can check the costs of a ticket, buy a ticket, or look at promotion deals. In order to make the promotions accessible to the customer, every time a visitor is presented with promotions, he is also given the option to buy a ticket. Draw the use case that fits the above description. So here you see a worker, a manager, one solution. If you assume it's like publish sizing, discounts, deals, buying a card. A deal. You could also just check the price of cards. The worker can add a new stall or a new attraction, and then he includes checking it. You have to check it. Make sure it's installed correctly, that new attraction. Use exercise 2. In the system proprietary collect money from an advertisement. You spend money for an advertisement, you collect money from an advertisement. Maybe means, I don't know, maybe like when you in the advertising, you can click on it and then you can register to pay that. The manager will be able to produce reports. The types of reports are review of the teachers and the system, and an income report. The teachers will be able to view his income. The teacher manager and the students will be able to view the various feedbacks. When viewing the feedback, it will be possible to generate reports of criticism of the system and criticism of the teachers. When viewing revenues, it will be possible to generate a revenue report. So here you see that the manager can do collecting money from advertisement, whatever that means. I don't know what that means. And here you see that there's a client, Kuak is a client, and there's two kinds, a teacher and a student. And the student can do certain things, but they all can do this. Looking at the class schedules. No, that's this one. What is this? This is also looking at feedback. Right, and the teacher can look at his feedback. This diagram where the include stereotype No, where will the stereotype include be expressed in the documentation for the use case? So what do we say about include?
It'll be, A will mention it. Like, if A includes.
Right, that's because the direction of the arrow.
You
A
needs to
include,
be-
what?
Like if you do A, then you must have B also.
Right, so A will make reference to B, but B won't make reference to A. B will just